Here we go. Okay. So 4.6, we're going to dig a little bit deeper into inverse trig. We want to be able to simplify expressions using inverse trigonometry, inverse trig functions. So we're going to get into that. I know we've done a little bit in the way of, inverse trig when it comes to solving right triangles and stuff like that. So we're going to take what we know about it and take it a step further. And use it to simplify other trig expressions and things like that. So go ahead and grab your notes. Let's get started. Today's notes hopefully won't be super duper long, but here we go. I feel like every time I say that, we end up with a really long class period. So hopefully that's actually true this time. Anyways, 4.6. Inverse trig functions. Okay. So the way that I want us to kind of start thinking about inverse trig is that you can use them to undo a trig function. And they're also useful for solving equations. So they undo trig functions and are useful for solving equations. They're also useful for simplifying expressions, which usually goes hand in hand with solving equations. When we get to chapter 5, we're going to be talking a lot about solving trigonometric equations. And within that, we're going to be using inverse trig quite a bit to help us out. Also, something to know about our inverse trig. It's going to be restricted to a particular domain. The domain is restricted so that we get a single output for each input. Because if you think about a trig function like sine, we end up with something that looks like this, right? And if you think back to when we were talking about inverses, remember this is the y, this is the x. If we were to switch x and y, that would give us the inverse function, right? And so when you talk about whether or not something is a function, it has to pass that vertical line test, right? In which case sine does. But if you want to check if the inverse is a function, it has to pass the horizontal line test. And as you can see, sine does not. Because if you were to draw a horizontal line across the sine function, it's going to intersect the function infinitely many times. So that is a problem. So we fix it by restricting the domain so that we get a single output for each input. So for example, with sine inverse, it can be represented this way, by the way, or you can call it arcsine. So the sine inverse function y equals sine inverse of x if and only if sine of y equals x, and it's going to be restricted for x values between -1 and 1. Oops, it's supposed to be an x. And y values between -π/2 and +π/2. So what that's going to represent for us is this right half of the unit circle. So we end up picking up every unique value of sine that way, because sine represents y on the unit circle, remember, and so we end up with all of the negative values of sine down here and all of the unique positive values of sine up here. So that's how we restrict sine. The way that we restrict cosine is a little bit different. So cosine inverse or arc cosine would be y equals cosine inverse of x if and only if cosine of y equals x, and it's going to be for x values still between negative and positive 1, but y values between 0 and pi. So what that's going to look like in terms of the unit circle and the way we restrict cosine inverse is it's going to look like the top half of the unit circle, because that gets us all of our unique x values. It has all the positive x values over here, all the negative x values over here, which gets us all of our values, our unique values of our cosine. Okay, and then tangent, we also restrict a little bit differently. So tangent inverse like that, or arctan. So similar theme here, y equals tangent inverse of x if and only if tangent of y equals x for negative infinity to positive infinity on the x values and negative pi over 2 to positive pi over 2 on the y values, which also, just like sine, actually represents the tangent values on the right half of the unit circle. And remember, tangent is sine over cosine, or y over x. So the reason that it goes from negative to positive infinity here is that as you get closer and closer to the tangent value down here, remember, tangent is undefined for negative pi over 2 or for positive pi over 2. So that's where it's approaching negative or positive infinity as the slope gets steeper and steeper. Or sorry. Yeah, no, we're good there. Yeah, so as the slope of this gets steeper and steeper, we get closer and closer to negative or positive infinity on tangent. Okay, so that's kind of a setup for what we're about to work with. So these are good things to have, just to kind of remind us what our domain is going to be restricted to here, so that we don't end up with a whole bunch of answers for the inputs and outputs here with sine inverse, cosine inverse, tangent inverse, so that we end up with one solution instead of lots of solutions. But the actual kinds of problems that we're going to want to do, we'll get to in a moment here. I'm going to let everybody finish writing, though, on this, since I went through this a little bit quickly. Also, if you have a unit circle in your notes or you have a unit circle nearby, there are going to be a lot of problems that we work with today that will involve wanting a solid understanding of the unit circle itself or being able to recall values from the unit circle. So if you don't have that, kind of memorized in your brain, then you might want to have a unit circle out either in opened in a separate tab or in your notes or something like that. Okay. Alrighty, so let's do some examples that involve these three functions. So, for example, we could be asked to find the arcsine of root 3 over 2. Okay. So for this, we would want to jump over to a unit circle. Unless you know that where or what angle corresponds to sine of root 3 over 2, or sine, or for which sine is root 3 over 2. But the way we would use the unit circle in this unit circle is quite a while ago in our notes. Okay, so here's a unit circle for us. So what we would want to do if we want to figure out the arcsine of root 3 over 2, we would want to find an angle for which the value of sine is root 3 over 2. So we're looking for the y value in the right half of the unit circle that is root 3 over 2. In this case, we can look over here. We go, okay, here's the y value that's root 3 over 2. The angle that goes with it is pi over 3, or 60 degrees. So that's our answer. That's what arcsine of root 3 over 2 is. So we're taking a sine value and we're spitting out the angle that generates that sine value. So that would be 60 degrees or pi over 3. Typically at this point in our mathematical lives, we're working with radians, but depending on the problem and what it asks for, you might also be asked for degrees. But that would be an example of how we find arcsine. Or here's another one. What if we did arctangent or tangent inverse of 0? All right. Well, on the unit circle, sometimes you have the tangent values written down, sometimes you don't. But we do remember that tangent is sine over cosine, right? Or y over x in this case. So arctangent of 0 is going to involve figuring out what angle spits out a tangent value of 0. So we want to find where the y value is 0 on our unit circle. So if we look back at our unit circle, where the y value is 0 within the right half of the unit circle, because that's where we restricted our tangent domain, that was at 0. So the angle 0, or 2 pi technically, but remember 2 pi is not within our domain, or our range, I guess, for this. So 0 would be what the inverse tangent of 0 is. So inverse tangent of 0 is just 0. Radians or degrees, 0 is the same either way. Okay, so I'm going to have you guys try a couple real quick. We're going to find, first we'll do cosine inverse of root 2 over 2. Secondly, you'll do arctan of -1. Okay, so go ahead and give those two a try. When you think you've got them, type got it in the chat, or if you've gotten as far as you can, type got it in the chat. Also, if you need a unit circle and you don't want to dig through all of your notes or scroll way back through Google Classroom, you can always type unit circle into Google real quick and do an image search, and one should pop up. All right, Jasmine's got it. Alicia's got it. All right, Paige, nice. All right, for those of you who think you have it, what do we think for cosine inverse of root 2 over 2? What do we get? You can put degrees or radians or both. All right, yes. 45 degrees or pi over 4. We got both of those answers in there. Yeah, because when you look at your unit circle, the value of the angle where cosine is root 2 over 2 is at 45 degrees or pi over 4 radians. So either of those will work. Okay. The one that's a little bit harder, or at least the one that I think is a little bit harder, is arctangent, or ain't really anything dealing with tangent here, because a lot of times we don't write all the tangent values around the unit circle. You could if you want to. You can write that off to the side on your unit circle. But oftentimes we don't. We just find tangent using sine and cosine, or using the y value and the x value at that point. So for arctangent of -1, anyone think they have it? And what'd you get? Nice, Carson, you've got 315 degrees. Let's write that down. 315 degrees. And then let's take a look at our unit circle real quick. I like that line of thinking. The only thing that's that I would slightly change about it is to find an equivalent angle that puts it into the correct domain for our inverse function. So 315 degrees is down here. It's also known as 7 pi over 4 radians. And it's the value where the x value is root 2 over 2 and the y value is negative root 2 over 2. Now, since tangent is y over x, if I put the y value divided by the x value, we do get -1. So if I put, we know tangent is y over x, so that would be negative root 2 over 2 over positive root 2 over 2. And the root 2 over 2's cancel, so we're just left with -1. So that does indeed work out with this angle, except the only thing that doesn't completely work out is that we want to refer to the angles down here as it's a coterminal angle, just the negative version of it. So typically we start our unit circle here and go, from 0 all the way around to 2 pi. This time we want to start at 0 and go backwards. So this angle instead, within the correct domain, we'd end up with negative pi over 4 or negative 45 degrees. So it's the same thing as this. It's coterminal to these. It's just within the range of values that we were looking for. So yeah, nice job, Carson. And that was the trickier of the two. But anyway, that's one kind of problem we will be seeing today when it comes to dealing with inverse trig functions. The other kind of problem that we're going to be seeing is going to involve more of the kind of canceling out of an inverse or canceling out of a regular trig function. Yeah, so the maximum, so if you're talking about like degrees instead of radians, this same range of values would be from negative 90 to positive 90 degrees. So the maximum angle you would want to spit out for arctan is 90. The minimum angle you would want to spit out is negative 90. So you would want to fit it within that, range of values there. Good. Okay. So the other kind of way of thinking about these that we want to have is in terms of using them to cancel something out. Or in some cases, you'll have to do something inside the function, like the inverse will be on the outside and there will be something else inside that you have to work out first before you can move to the outside. So we're going to deal with both of those cases. So when we were dealing with inverses of regular functions originally, you would see occasionally something like f of f inverse of x. And then the idea behind an inverse is that if you do the original function to the inverse, they cancel one another out and you're just left with what was inside, x. It also works in the reverse fashion. You end up f inverse of f of x. The inverse cancels out the original function and you're just left with x. The same thing works with sine, cosine, tangent, inverse. And we kind of saw this a little bit when we were dealing with right triangles and stuff like that. But so if you were to do something like, if you were to see sine of sine inverse of x, the sine and the sine inverse cancel and you're just left with x. Same thing if you were to do like tangent inverse of tangent of x. The tangent inverse cancels the tangent and you're just left with x. This is going to be something that's really useful to us when we're solving equations, because if you're trying to get rid of a trig function or something like that to get the variable inside, then you'll end up doing an inverse to both sides of an equation. So when we see something like this, we want to be able to recognize it and cancel it out. For example, if we were to have cosine of cosine inverse of root 2 over 2, you would want to see that and be able to evaluate by canceling the cosine with the cosine inverse and getting root 2 over 2 for your answer. But they can only cancel like that if they are the same type of trig function. A cosine and a cosine inverse can cancel each other out, but a cosine and a sine inverse cannot cancel each other out. So occasionally you'll see something like this other case here, where we have something like sine inverse of cosine of pi over 6. And if you want to evaluate that, you first have to start on the inside and evaluate the cosine of pi over 6, and then you can use that to simplify the sine inverse portion of things. So this one is more like the kind that we did up here. It just has an extra step to it. first you figure out what cosine of pi over 6 is. And we know from the unit circle that cosine of pi over 6 is root 3 over 2. So then that means that this is equal to sine inverse of root 3 over 2, which we already know from our example above is pi over 3 or 60 degrees. Typically, we would answer it with pi over 3. So that's another kind of problem that you might see. All right. And then the last example is going to be another one that's kind of like this, just the other way around. Instead of having the inverse on the outside, it's going to have the inverse on the inside. So we know how to deal with both of those. Okay, so this one will be tangent of arcsine of -1/2. So again, just like with this one above, we had to evaluate what's on the inside first. So the first thing we would want to do here is evaluate arcsine of -1/2. So we would jump to our unit circle and go, okay, well, where is the y value -1/2? That's down here. And that's at 11 pi over 6. But 11 pi over 6 doesn't fit into that range of values from negative pi over 2 to positive pi over 2. So I would want to fix this really quick and go, okay, 11 pi over 6 is the same thing as -1 pi over 6. And this would be the value that fits into my range that I want to use. Or you could call this -30 degrees and this 330 degrees. Either way. But the important thing here is then that we go, okay, then we want tangent of negative pi over 6. Or really, you could find tangent of 11 pi over 6. It's going to get you the same thing in this particular case. And then that, we would have to go back to our unit circle to figure it out. It's y over x, or you could consider it sine of 11 pi over 6 over cosine of 11 pi over 6. Either way of thinking about this is fine, but what we want to do then is look at our unit circle and notice that the y value at 11 pi over 6 or at negative pi over 6 is -1/2, and that the x value is root 3 over 2. And then we want to simplify that fraction, so we would flip and multiply. So 2 over root 3, which gives us -2 over 2 root 3, which is -1 over root 3 when you simplify. And then we can't have a root in the denominator, so instead we would rationalize that to get -root 3 over 3 by multiplying by root 3 on the top and on the bottom. And this would be our final answer. And this is about as complicated as these get. They don't get a whole lot worse than that, which is good. Also, you've probably noticed that, especially from before we were doing right triangles and whatnot, that you can do sine inverse, cosine inverse, and tangent inverse in your calculator. If you were to do such things, like type tangent inverse of 11 pi over 6 into your calculator, that's what you would end up with. Or sorry, not tangent inverse. We were doing tangent of 11 pi over 6. My bad. But you can also do tangent inverses in your calculator. But you do end up with decimals. It doesn't typically give you the whole rationalized exact answer here. It depends on the calculator you have, of course, because there are calculators that will give you the exact answer like this one does. It's funny how this one's the graphing calculator and this one's the non-graphing, just scientific calculator, but it gives you the exact answer. But anyway. So if you want to check your answers and stuff like that, especially, you can do so using a calculator. You just might want to start recognizing some common forms of different that you'll see and stuff like that. Like when you put root 3 over 3, or when you get something that is root 3 over 3, that's approximately negative 0.577. Usually you want the exact answer, but if you're trying to learn to recognize them in the calculator, that's approximately that. Root 3 over 2 is approximately 0.866. Root 2 over 2 is approximately 0.707. So those are some common different ones that you'll see for sine, cosine, and tangent. Let's see. I guess root 3 is also another one. 1.732 approximately. So if you are looking to check answers and you're using a graphing calculator or a Desmos or something like that that gives you decimal answers, these are some common ones. Again, if you're using those to check your work, what I recommend using, though, is the unit circle and finding the exact answer that way. Since then you'll know that you have found the correct exact answer. Okay. So those were a couple of more complicated examples. Any questions from either of those? Any numbers we're not sure where they came from or anything like that? Okay. Then I'm going to give you guys one to try, and then we will jump to the homework assignment. We're going to do, or actually I'll give you two. First one we'll do cosine inverse of sine of 5 pi over 6. And the second one will be tangent of cosine inverse of we'll do negative root 3 over 2. So go ahead and try simplifying both of those. When you think you've got it, type "got it" in the chat. All right, so you're on the right track if for 5 pi over 6, we know that sine is going to be 1/2. So we want now cosine inverse of 1/2. So then simplifying that. And then cosine inverse of -√3 over 2. Well, the place where cosine is -√3 over 2 is at 5 pi over 6. So then we want tangent of 5 pi over 6. All right, so then simplifying, we want to find the place where cosine is 1/2, and the angle that that happens to correspond to is pi over 3, or 60 degrees. So if that's what you got, you are correct. And then for tangent of 5 pi over 6, that would be where we take sine of 5 pi over 6 over cosine of 5 pi over 6, which is the y value over the x value there. Which is then going to be let's see, that's 1/2 over -√3 over 2, because that's in the third quadrant or second quadrant. Ugh, yikes. So that would be negative and positive. So then we flip and multiply, and we get, so times 2 over -√3. The 2's cross cancel, 1 over -√3, which is -√3 over 3. For our value of tangent. All right. Any questions with either of those two? Any numbers we're not sure where they came from? Steps that don't quite make sense? Okay, then let's go ahead and take a look at our homework for tonight. It's going to be a worksheet, and it shouldn't be a super long one, especially if you're starting to feel more comfortable with these sorts of problems. It is posted in Google Classroom, 4.6 worksheet. We're going to do all of these problems here. So we've got 1, 2, 3, 4, 5, 6, 7 problems that are more like the first type that we did, where you're doing arc sine, arc cosine, arc tangent of some value. And then we've got more of them, 6, that are more like the kind that we just did, where you have to simplify the inside before you can work with the outside. Okay, so just like usual, do your work on a separate piece of paper, or you can convert this into a Google Doc if you would like to and put your work on there, or edit the PDF however you like. Make sure you show your work, upload in whichever way you choose to that assignment. And that's everything. I will post an exit ticket in a little bit, but unless you've got questions or concerns or anything like that, you guys are free to go and enjoy the rest of your day.